Hello, Impact users, and welcome to today's webinar. Today, we're going to talk about beam, column, and hollow core elements in Impact Revit. I can see people are joining us, and while everybody's online here, I want to use the time to introduce myself and to introduce the plan for today. My name is Daisy Slava and I'm a part of Impact Revit team in StruSoft. I'm connecting with you from the city of Aalborg in Denmark, and I'm going to be your host for today. This is the first out of three webinars we are doing. It's a continuous story, it's a series. In which one of the webinars we're going to focus on a particular element types. And today we're going to talk about the structural framing elements of beam, column, and hollow cores. Now, what you can expect from today's webinar is that we're going to model with the help of Impact Revit, column, beams, and hollow cores. But not only model, we're also going to go in deep and solve some details. Some examples you can see in here. We can talk about how, with the help of Impact, you can do a beam end details, insert such kind of a fixing, recesses. We're going to talk about end details of hollow cores and how, with the several clicks of the mouse, you can insert recess for a bunch of hollow cores out there in your model. We're also going to demonstrate the reinforcement, which I think it's a very, very hot topic within Precast and Revit, and how to reuse a reinforcement that you have drawn in Revit and save it with the help of templates, use it on all your column and beam families in your model. Once we're done with the modeling, we're going to save the elements. We're going to generate shop drawings. Again, here we're going to use template with the help of a shop drawing template. I'm going to show you how, with a few seconds, you can have the front views, the sections, the schedules that you've set up in your template and get some really presentative precast detailing of a shop drawing. And we're going to see the elements in Project Manager, which is our central tool in the Impact 3D BIM precast system. We're going to view the elements, demonstrate the connection between the Revit design and the Project Manager, and I'm going to give you ideas of how to continue this precast process. A lot of ideas here, so let's jump into it. I have set up my model. I don't want to use time on setting up. Today we're going to model, we're going to focus on the most important part, the precast detailing. Okay, so here we are in my Revit model. I've connected with the database. I have a Impact Revit project, and I have here in the Impact tab the column, the beam, and the hollow core. The three elements that we are going to talk today, they are placed in the start of the Impact tab. I've also prepared a prototype of reinforcement that I want to use when doing my element, and it's something, it's a sketch that we're going to use for demonstrating how to create those rebar templates and work further with them in Impact. Let's jump into it and start with drawing the columns. The first thing I want to do is, of course, check the level where I am. I'm at level 1. Yes, that's correct. And I have some grid lines. And I'm going to draw the columns that are placed on the outside of my structure. Here I am. And let's see. it's placed up to level 2, which is actually not what I want. It's very important to control that from the start, so you don't need to edit your element. So when you say draw column, the first thing you need to do is, of course, make sure that's a vertical column, and make sure that you have control over your levels. I want to go up to level 3. So I think I'm on my way now. Yeah, you can see on the right what's happening, and Revit has this very good tools for previewing your design. So I think we just can go and use it by dividing the screen. I'm jumping now to grid line C, and as I mentioned in the start, it's just one of a series of webinars. So we've planned to continue the model after today, um, making a more complex structure in our next webinars coming up in March and April. Okay, we have some columns in place, and here I wanted to notice that while we're drawing, Impact has calculated the weight of the element and inserted a lift, casting material, a lift that is going to correspond to the geometry and the weight of the element. So it's calculation done in the background, and it's done with the help, of course, of predefined settings by the user in the element definition. I'm going to continue with some columns that are going to be used for my ledge beam. So I'm just going to go in here and insert them. They need to go up to level 2. Okay, the same story here. We have inserted some casting materials and a lifting hole that is used for lifting on the building side. Once we're done with those, we're going to go and draw some beams. And for that, we're going to use the draw beam command. We're going to start with some rectangular beams that I have predefined. And we are on level 3 right now because they need to go up in the structure like this. So all the way up to the level 3, we're going to have some beams in our model. And while I'm drawing the beams, I want to use the time to mention that all these following menus that we're using today for beam, for column, for hollow core, they are filled with functionalities which each one of them has its story behind its story, its purpose. Um, a lot of them are started actually by users just designing to optimize our standard. We're going to continue here with beams, and we're almost ready with them. Let's see. Yes, it was this one. We missed a bunch of them before we get to the more interesting part, which is the curves. And what I've prepared today is actually a tool. We have two tools for drawing curves. I've prepared one that I think is really good to know if you haven't used it before. And it's the one that detects intersection between column and beam and automatically insert curves. So I think this is something it's really good to know if you haven't used it before. Um, Before we do it, we just need 4 ledge beams in here, and we can jump to the corbel. We're going to use the section type called ledge beam, and we're going to draw. Now we need to think. Now we are on a level 3. I think we need to be here because then we don't need to move the element. Yeah, good. So we go to draw a ledge beam. These are going to be the ledge beams on which we're going to place our hollow cores later on. Okay, good. Then let me see. Yeah, it looks okay. It's important that we draw them in the correct direction so that we can later on support the hollow cores on them. Good. So far, so good. We're ready to jump on the corbels. Now, in order to draw a corbel, we have two functionalities. The first one is insert corbel and a draw corbel. It's described here on the helping text on the right. What is it? But basically, a draw corbel is something I would advise you to use on a single detail solving if you have just a single corbel to draw. But if you are going to draw corbels in a structure like you have in here, so I would say select the structure and let impact detect the intersection between a beam and a column, because then you can say choose it, choose the family, and just insert it. What impact is doing now is just taking the corbels everywhere where we can detect um, intersection between a beam and a column. And now probably you want to have this corbel going all the way from one to another edge of the beam, and for that we have functionality. It's the one in here called full width. So what I'm going to do is to select all of them, select all corbels that I just drawn, and I'm just going to say full width. Okay, and then impact is going to find out which is the host family, and then we're going to make the corbel full width going from one to another part of the column. Okay, so far so good. We have corbels, we have um, columns and beams in place, but we need to solve a detail in here. You see, our corbel has a socket, and we need a circular recess um, to get to the socket in the corbel. We need to solve this detail. And for that, I would use a functionality called um, beam ends. That's if you select the beam and you go in the following menu, um, you go to this called edit beam command, and here there is a tab called ends. So each element has its edit command, and it's of course adjusted to the um, character of the element. When we have beams, we need to edit probably add angles, we need to add recesses on the left or the right end, or we need to add fixing. So fixing is what we're doing right now, and it's a circular, and you see its dynamic picture here on the right, which is guiding you as a user. It's a symmetric one, and in this case, I need to fill in a parameters ALL1 like this, and I've measured in advance. That's why I know what to fill in here, and I've already can apply this to the right side as well, so that it just comes both on left and right. If I say apply, it's saying that the weight has changed, and we know that impact detects something happens in the element. So we do a lift checking, And here it is. We actually have some fixing holes on place, and it looks actually quite okay. And yeah, here actually we're going to demonstrate the power of impact because I can just say select all instances again, um, visible in view, and can probably exclude the one that we just made and use edit beam again. And this time I'm going to do this the same, but for all elements. So this is where you don't need to do it for one at a time. You just go and apply these changes for all elements. We say apply, and the fixing is being inserted on all elements. It's where we have the corbel, and we have solved the detail now because we have a fixing, a circular fixing. Good. Let me see here. We have the corbels and we have the fixing in place. Now it's time to go to one of the most interesting part, and that's the reinforcement. Now, how I usually would do this reinforcement is you're going to draw it with a Revit functionality, and Revit has a perfect tools when drawing reinforcement. Um, but we're gonna take it to further to a higher level where we say we don't want to draw this on each column on each element. We want, of course, to save it. Probably it's a typical detail, reinforcement detail for the bottom, for the top. We want to save it with the help of a template and we want to reuse it. So what you're going to do is you're going to go to the reinforcement tab here in impact and in rebar template. So it's just going to um, go and save a template. If we take a column example, you're just going to say new, we're going to say A6, and then we're going to say N plus A6. That's what I have now. And impact is just going, it's saying that it's not mirrored, that's fine. Impact is going to detect the rebars that you have in there. We say okay, and our template is on place. Okay, and again, you don't need to draw it on each column elements. I can just select them, select all instances, visible in view, except the one here, and you can apply the rebar templates. You say apply rebar templates, and the one that we just made right now, it's A6. All the rebars are coming on place. So that's where it's saving time for you. It could be, and in this particular rebar, I say I have a combination of shapes. Doesn't need to be throughout the whole element. It could be just part of it. It could be the top, it could be the bottom, the middle part, around a detail. But you can also do a component. You can see here I have a corbel family. So I've done a rebar template out of it. So if I go and select all my corbels in the structure, let's see here, right now I can see I have all my corbels selected. I can say apply rebar, and that's, yeah, impact the test as a corbel. I have one of them here, and here it is. I'm going to have a reinforcement for everywhere where I have a corbel in my model. It's family based, right? So um, it's really important to say that if you had same family within the model, but a different type, different dimensions for a type, it will also apply. So it's family based that can be used within types of the family. Like this one, right? We have We have two types, and the rebar template that I just made and saved in the database can be used for both. And you can have this on a common level. It's a sandwich wall, insulated wall, structural framing elements, components like corbel or panel thickening. It's pretty useful. Now we're going to demonstrate how to apply this for a beam, and I have a ledge beam in here, and I'm gonna go and use it for my 4 ledge beams, right? And yeah, here I have, um, let's see what we have for beam. We have a rectangular beam. This probably it will work. So you can either select all instances, or now when I'm just going to do like this and finish here on the top. Um, I can do some reinforcement. It could be a base for reinforcement you're doing. It could be just as I said, a detail of it, but it's really powerful tool, which I think you should know about. Let's try this for our columns. And just like that, we just have some reinforcement in my elements. And the last thing I want to mention here before we jump to Holocaust is that um, you can see in here, I have actually some reinforcement added to a component that is to a casting material. And I think it's really, really good to see that this is also something we can do. So if you have a component which has requirements for, in this case, it's lift. So you see every time you use this casting material, for example, lifter, you need to have a rebar around it, one shape, two shapes, whatever. You have actually a possibility to set it up in Impact so that Impact can automatically insert the rebar for you. It's a new functionality that has come in the recent years, and if you don't know it, I think it's good to see how it functions. So you see, here's my family, and it's called 0189 in the Impact database. So what I've done is basically I've gone into 0189 definition of a casting material, and here I've set up in the reinforcement tab, I've set this rebar. So every time I insert this in my model, a rebar is going to appear, and again making your work easier instead of manually adding it each time you use the family. Option that I think it's especially relevant for example, lifters. Okay, good. So we have some reinforcement in place, and on my next webinar, I'm going to talk about reinforcement templates. It's a tool used for walls. So I think here it's a little bit, it's important to differentiate. It's also a very important tool. We use it for walls, but structural framing elements, I think we're more into this tab when we are doing the rebars. And of course, some more functionalities in here, which I think you should give them a chance if you want to explore the reinforcement in Impact for Revit. Now I think we're ready to go and draw some holocaust, and we're gonna do that here on our ledge beam. So let's jump into it. Let's see, we need to plan a little bit how we're gonna draw them. If we draw a section and we go to it. Mm. So here I can see my ledge beams, right? So I need to see how much I want the holocaust to lay on the ledge beam. So I'll probably go and measure how much we have from top to here. It's 440. And it's good to know that when we place them in the model. They're going to be placed on level 2, I can see. So I go on level 2. And the way I really like drawing hollow cores is actually with the help of model lines. And yeah, it's a pretty much drawing style that I know each designer has, but in that way, I feel I have more control over it. And um, if you use the model lines, you can do as I do later now. On this webinar, I'm just going to select them and draw hollow cores on top of them. So I'm just gonna go here. It takes a little bit more time, but again, it gives you a kind of control over the shape. So we'll do it that way now. But of course, impact is pretty often to different ways of drawing it. If you want to draw them, you're gonna go to the hollow core folding menu with all its functionalities, and of course, the first one you're gonna do is say draw hollow core. Here I have some hollow core in my definition. I'm gonna say um, first we need to define the boundary. I'm gonna say pick model lines because I have some model lines on my model. You can also draw rectangular, pick enclosed area, pick points, pick floor. It's a various possibilities here. So I pick the model lines, and impact suggests that it looks like this. You can select the direction by going like on this button. Of course, I would like to have them resting on my ledge beams. Then you can go and choose support length. Here you can go from edge to edge and set a support length. You can go and yeah, try it out. It's a really powerful tool in this webinar. I'm just going to set it to 0. But basically, it gives you possibility to go and find support length for each edge. Okay, so I want just to have it a 0, and we had the 440 of offset. We measure it, and what else? Impact gives you possibility to insert a partial slab or um, just say that we don't want it. Say I don't want to insert any partial slab. You can just um, yeah uncheck it. And the strand patterns. In my definition of the hollow core, try to look at the picture here. I have different strand patterns, so you can choose some of them, the ones that suit to your project, and say okay. Okay, so now our hollow cores are being inserted. And yeah, let's take a look at them. Impact is working. Um, let's see how it looks. First, we can go and see how it looks on the section. If I say go to view, yeah, we've actually done pretty well. It's there resting on the ledge beams. But take a look in here. We have some details in the end, right? And if you look at the 3D view, we have some um, we have some recesses, so to call it. And in impact language, we call that in cap. So basically, what you have in here is you can automatically insert geometry on your hollow core. So let's take this one, this hollow core, and go to edit hollow core, right? And here you can yeah, you can go to the InCap tab, and this is the InCap that I've chosen when drawing them. I have several in my database, so this is just an edge without any specific shape. can go and see here. I have some parameters that can decide the recesses. Very powerful tool if you know they are repeating geometry within your hollow core floor. Um, yeah, and you can just play with it and see what works for you. Um, what seems good. So we could say okay, and now you can see the shape is changing. We're going back to back to just this rectangular form. I think if we go to the 3D without rebars, you probably see better. See 3D here. Yeah, it gives you a very good picture of how you can just change it. You can also, select, let's say for some reason you wanted to change for, um, all those on this size. So you can just say, again, edit for multiple elements, and you can either select all edges or just one of them. The um, it's up to you basically, and it's just important that you have this, very powerful tool that can just do changes like this in the geometry in a couple of seconds. So this edge right now it's just straight. Okay, and when we talk about the Holocaust, we have really, really um, interesting tools about that. You can go and explore more in this following menu. The last thing I want to do now is draw the pre-stressed beams on the top, and then I think we're ready to start saving the elements. I'm gonna go into I'm gonna go into the 3D here and level 3, and drawing pre-stressed beam is just selecting the type, the element type in here, and here I have a pre-stressed beam. So yeah, gonna draw them along the mm, looks good. Looks good. We're gonna see the strands just in a while. And the next step from here, according to the plan, is that once we have them in place, I would like to save the elements and I would like to show them in our project manager. We are in a good time, so we're also going to do some shop drawings. Definitely worth seeing when we talk about the structural framing elements. I'm going to demonstrate now how to do the shop drawing as well for an element, which is again a tool that it's worth giving a try when you work with impact. Okay, we have the pre-stressed beams, and here you can see that we also have the strands uh, in the pre-stressed beams. And I think that now it's time to start saving the elements. You can either do that by selecting an element type at once, or you can just do all of them at once. I say select all instances in visible in view, right? Beside this one, this is my prototype, and say each um, um, each functionality has its saving functionality. Each element has its saving functionality, so probably we can just do like this. We can say can select, cross-select. I think that's the easiest way. Let's do it that way. And say save columns. So basically what we're going to do now is that we're going to save the columns in our project. And here it is. Um, we're saving them to the database and all the information about them. Geometry, the components, casting materials, um, reinforcement, it's going to our database. That's what we're doing now. Because once we have saved the element, we can preview it in our central tool, project manager, but we can also make a shop drawing out of it. Okay, so I cross select again and I'm gonna save the beams. So save the beams. Let's see, impact is working right now. Processing 26 beams are detecting, and we start saving them. We have rectangular beams, a sloped I shape, which is the pre-stressed, and we have some ledge beams on which we rest the hollow cores. Okay, that's the beams, and the last thing we miss is again cross select. You can also select an element by element, but this is the most time consuming. Save hollow cores, right? So we need to save the hollow cores and we say save. And now we are ready after the hollow cores save. Now we're ready to open the project manager. So let's wait 2 seconds more. And we see we're also going to demonstrate now this collaboration between the Impact Revit design and the project manager. Project manager is basically um, previewing information from the database. That's why we need to save the elements in advance. So here is my project. I've opened my project in the project manager and I'm on the model preview and I say reload. Here PM project manager is taking the data out and we can see our detail, precast detail. Yes, here it is, our building. Beautiful. That's what we've did today. And if you press on an element here, um, you can go and see information about it. You see it's a pre-stress beam, and all this is data that you go and read on the elements. We can go here and see hollow cores. We have columns and beams. Um, Another tip here I want to give you by saving is that I don't know if you noticed, but when we were here on the save, there is a possibility to save an OBC file, which it's a functionality. It's been there for quite a long time, but basically what we do here is that we save a file that gives a very detailed preview of the element. So a very, very good tool to see how the preview now in Project Manager is coming, and you can see the difference. Um, Probably if you go here, um, we go and save. See, this is a column save without WC. This is with WC. So you can imagine all these small components that you have on your element, like casting materials. They're going to be previewed in here, right? Another tip about saving is that I know some of you are interested in IFC files, and there's come a new setting here. It's a project setting. So if you go into Impact and this, you can see export elements to IFC while saving. So while saving the element, the Impact is going to make an IFC file of the element. And later on, you can go and preview it, find it in the project folder, or you can use it when working with Project Manager, which is a powerful tool for designing in I mean, is summarizing a precast process. Later on, you can just take an element and just put it here on the. This is a precast bed that I have. You can just take it and just yeah, just drag it in here. Um, yeah, it's also a tool that has very good control because here it says that I'm messing up with the dates right now, so I don't want to do this. But just to demonstrate that once you have your detail, precast detailing here in Revit, you go and move further with the project. These are some walls drawn in Impact for Revit. You go and use it further where you're going to plan your precast beds. These are some beds for producing the elements, planning the transport, and so on. You can go and also take reports out of it. Everything is now in the database about these details. You can use the full potential of impact. And last but not least, I would like to demonstrate how to do a shop drawing. So once we have it here in Project Manager, which means that we have saved the element. And for doing shop drawings in Revit, we're using this drawing tab, right? So we're just going to go and say create shop drawing and just going to say, okay, we can do for a column and you can choose this one. It's um a one. I think a sweet little one there hiding in behind. Let's see how our shop drawing is gonna turn out. Impact is working right now. It's what we're doing is based on a shop drawing template that the user has prepared. We are actually creating a sheet, and yeah, we are making a shop drawing. So here is our column, the one that yeah, you can see in here, right? So what I've did is I have this template and I've decided that I want to have a front view, I want to have yeah a 3D view with reinforcement. I want to have a section. I probably want to also have some reinforcement with pictures of the shapes and so on, company information, information about the project, everything here. If you've done your template, you can see it comes up within a second. And here you have the shop drawing. From here, you can, yeah, you can go and plot it. Also, we have plotting tools, or we can, yeah, go and preview the shop drawing in Project Manager. We can see here, this is um, this is sheet 13. That's the sheet that we're working on. So if we update here in reload model, we can also see our shop drawing in Project Manager. This is also a good example of the connections that we have between the Revit design and yeah and Project Manager. So here it says we have our shop drawing. Okay, good. I think we'll stop here for today. And as I said before, uh, we are just on the first. That was Precast Detailing Part 1. It's a series we're doing this spring. So you can be really looking forward to the next part, which is the wall and slab. We're going to focus on wall and slab elements, and in April we're finishing with form slab double wall and linked elements, which is a element types that yeah they deserve a webinar on its own. You can go and look more information about Impact Revit on our Impact Wiki page, uh, LinkedIn, and our StruSoft channel in there. It's worth following together with YouTube. Otherwise, our webpage is where you can find all the upcoming webinars from StruSoft and sign up. If you have any questions about today's session, you are more than welcome to write to me. I'm pretty happy to come in contact with you and answer your questions if you have any. Otherwise, I say thank you very much for today. It was a pleasure to go with you through structural framing elements and hopefully see you on part 2 in March. Bye for now.